So classified paper 6 experimental technique and analysis questions. We solved till question 15, so 16 onward we'll solve today. The table gives four different alcohols are there, as you can see: butanol, ethanol, pentanol, and propanol. Because they have the common functional group, that is OH, that's why the name is ending at OL. The apparatus shown can be used to obtain propanol from a mixture containing butanol, ethanol, pentanol, and propanol. As you can see, the apparatus, that is a fraction distillation. Name the apparatus label as A.
Thermometer, and B, Liebig condenser.
Right. So you can also say condenser or you can say Liebig condenser. Both are correct. The next one is name this separation method. So what we called as
Fractional distillation.
fractional distillation. So 1 mark is for writing fractional and 1 mark is for writing distillation. How we know that the diagram is distillation or a fraction distillation? Yeah, that's a good question. Look, how you can simply identify whether it's a distillation or a fraction distillation. The simple difference is that there is a fractionating column, like the beads are there. If the apparatus is for fractional distillation, then these beads are there. But if it is a simple distillation apparatus, then we don't have these beads. This part won't have beads. So you can clearly identify that it's a simple distillation rather than fraction distillation. These are the glass beads. You can see small spheres in the figure. These are the glass beads, and this part of a like apparatus is known as a fractionating column. Because what happens when some of the liquid might also vaporize, but it cannot pass through these glass beads, so it condenses back and return to the. If the vapors are having a very high pressure and temperature until they reach a boiling point, and they escape out, and then a condenser turn them into a liquid. So you can simply identify from this part of an apparatus whether it's a fractional distillation or a simple distillation. Explain why it is safer to heat a mixture.
Because alcohol is flammable.
Flammable.
Alcohol is a flammable liquid. That's why we use a here you can see electrical heater or a water bath rather than directly exposed to the flame. Describe how propanol could be obtained from a mixture. Use data from the table. How we can obtain propanol from this? So if you want to obtain propanol, which is 97.
So
First, we
it's
will
heat
need to
until
distill over
the
ethanol.
temperature on the thermometer will be.
Sorry, now continue. Because Muhammad Ashraf, your audio continuously is like echo. I don't know why. But
Sorry, mister. I'm so sorry.
you can continue. Anyone, Rafi, if you want to answer, you can answer. Any one of you can answer.
We will first need to distill over ethanol.
Yes, because yeah, that's right. First, we have to heat till the boiling point 97 till yeah, but this is not the full answer because first thing is what first we'll have ethanol will be there because ethanol is 79, the one which is having a lower boiling point. So heat to remove ethanol first and then continue the heat until we reach 97 and we collect propanol. So 1 mark.
Propanol in a different receiving flask we can mention.
Yeah, you can mention that as well. But the mark distribution is 1 mark is for mentioning heat to remove an alcohol. Like first we have to heat alcohol, heat supply heat energy and remove alcohol. And that is ethanol. And then because it is 79, so once the temperature is 79, first we collect ethanol. Then we change this. Once the temperature start to rise, we change this beaker here, and we continue until we reach 97, and at 97 we'll collect propanol. So you have to mention both of them. Explain why the apparatus in the diagram can not be used to obtain butanol from a mixture. From this table, you can identify. Why a butanol cannot be obtained from this apparatus.
Because the water in the water bath will evaporate. For a water bath, we cannot exceed 100 degrees
100,
Celsius.
yes. Because what we are doing, we are using an electrical heater, and from electrical heater, the energy supplied to water. So maximum temperature of the water can be 100, because after 100, this water will start to boil, and it will turn into vapor. So the temperature of the flask cannot exceed more than 100. Yes, the boiling point of a butanol is higher than the water. That's why we cannot use this technique to obtain butanol, or even pentanol cannot be obtained by this way. But because both have, so any substance which is having a higher than 100 cannot be used. We cannot use a water bath to separate. Then we have to directly expose to the flame, like using a Bunsen burner, and increases the temperature. So this question is about the analysis, like identification of the ions. So solid Y and Z are analyzed. Test was done on each solid. Test on solid Y. Solid Y was dissolved in a distilled water to form a solution, and solution Y was divided into 4 portions. When we add aqueous ammonia, when aqueous ammonia was added, dropwise a white precipitate formed, which was insoluble in excess. So what this
Aluminium
given?
ion.
So aqueous ammonia is there, drop a white precipitate. Better in the exam, you will have that the test for the ions key will be there. You can use that. But once you carry out, like, do different types of questions related to this, you should memorize as well. That's also fine. So when you check, when adding an aqueous ammonia, a white precipitate is there, and which is insoluble in excess. So there are two white precipitate. One is due to aluminum and another one is due to zinc. So if you check the question, in the question, an aqueous ammonia was added dropwise, a white precipitate which was insoluble in excess. So if the white precipitate and insoluble in excess, so this shows that this solution contain aluminum ion. So this is an ID, aluminum ion is there. Then aqueous sodium hydroxide, this also confirmed that there's an aluminum ion. Then aluminum foil, when aluminum foil added sodium hydroxide and aluminum foil, this is a test for nitrate ion. For a test, to test the nitrate ion, we add aluminum foil and then heat. So what we observe, a red litmus paper turned blue. If a red litmus paper turned blue, the gas which is given off, the gas is ammonia, and the ion which is present in the solution, that is a nitrate ion. So one of the tests shows that there's an aluminum ion, another one shows there's a nitrate ion. So it shows that this is aluminum nitrate. And about 1 cm cube of nitric acid followed by silver nitrate. This is a test for the halides. So this is a test to check the presence of chloride, bromide, iodide. And because it does not show any precipitate, so it means no halide, or halide is absent. Like there's no halide present in this, or no halogen. Name the gas given off in test 3. So which gas is given off in test 3? So that is ammonia. Identify solid Y. What is solid Y? From one test we identify it is aluminium. Another we identify it's nitrate. So it is aluminium nitrate. It is acceptable that you can also write a formula of aluminium nitrate. But if you write a formula, then it should be correct. If you write AlNO3, then it is wrong. Why? Because it should have a correct formula. Aluminium valency is +3 and nitrate is -1. So it is AlNO3 in a bracket 3. A strip of universal indicator paper was dipped into the fourth solution. Why? The universal indicator turned orange. What additional information this give about the nature of a solution if it is orange?
Weakly acidic.
Weakly acidic or weak acidic solution, or even acidic you mentioned, that is also fine. Weak acidic, acidic because red, orange, yellow, these are the indicator colors in acidic. Because they asked what additional information so information they like what this given idea it's about, so it refers to that the solution is acidic is the right answer rather than mentioning a pH of a solution. Then another test on solid Z. Solid Z is iron 2 sulfate. So they already mentioned that there is an iron 2 ion and there is a sulfate ion. Solid Z was dissolved in water to produce solution Z. And solution Z was split into equal portions. First one, aqueous ammonia was added dropwise and then an axis. So if we have iron 2 ion and we add aqueous ammonia, what is the observation?
Green precipitate, which is insoluble.
Yeah, so green precipitate which are insoluble in excess. And if we leave these, so green precipitate which are insoluble in excess, and if we leave it, then it will turn brown at the surface because then iron 2 will be oxidized to iron 3. Like oxidation happen, oxidized by the air. So answer for this one, you will mention it will be green PPT. And insoluble in excess. The second one about the 2 cm cube of a hydrochloric was added to a second portion. When we add hydrochloric, what is the expected observation here? What we will see? There will be no visible change or no reaction is there because this is not like a carbonate. If it was a carbonate or if it was a metal, then as a result, it will give no visible change or no effect, you can say. Both are correct. Then solution, the part F, solution E was warmed. Now it is warmed. Now when we add hydrochloric acid and warm the solution, this is actually a test for sulfite ion. Sulfite ion. So already we know it's a sulfite ion is there. So you can see for sulfite ion how we carry out a test. Small volume of acidified potassium manganate is there. Like acid is there and then potassium manganate. As a result, acidified potassium manganate changes from purple to colorless. Yeah, we must heat as well. We have to supply heat energy. So a solution in E was warm and a piece of a filter paper soaked in acidified potassium manganate was held at the mouth. So what will be the result here?
Turns colorless from purple.
Yeah, it will changes the acidified potassium manganate turned from purple to colorless. And why turn from purple to colorless? Because that sulfur dioxide gas is given off. And about 1 cm cube of a nitric acid followed by few drops of barium nitrate. So barium nitrate.
White precipitate.
Barium nitrate.
No, it is.
Yeah. Barium nitrate.
No change.
Which one you're talking?
G.
Yeah. So if no for G, remember one thing, sulfate and sulfide both have the tendency to give a white PPT with barium nitrate. So they both have a capability, tendency to form a white precipitate.
But we confirm by the other test of potassium manganate 7.
So here about dilute nitric acid followed by few drops of a barium nitrate. So barium nitrate combined with this sulfate ion is there. This okay. This was sulfate. I thought it was sulfide. So this is sulfate. As a result, it will give, because it's a sulfate is there. So this part will be no change. Why no change? Because I thought it was sulfide. If it was a sulfide,
G would be then white precipitate.
yeah, and then SO4 sulfate is there, so it will give a white PPT. If the question we solve the same question and we consider that it was iron to sulfide, then what we did, because I thought the question was about sulfide, not sulfate.